to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. We go deep. We go all the way down. With me today is Lior Gavish. He is the CTO at Monte Carlo. Welcome to the show, Lior. Would you mind introducing yourself a little bit more, please?
Hi, Jesse. Nice to be on your show. I've watched a few episodes and really enjoyed it, so it's nice to be here. My name is Lior. One of the co-founders of a company called Monte Carlo. We're the data and AI observability company, which means that we help data and AI teams build reliable, trusted agents, data pipelines, ML, really anything that data and AI teams are working on. And we do that by helping adopt a process, if you will, that's similar to DevOps, with good monitoring and observability on all these systems. We'll probably talk more about it later. I'm originally a software engineer by training. I've worked in a lot of startups throughout my career, and about 6 or 7 years ago, I started Monte Carlo with my co-founder Bar, whom I'm also married to. Full disclosure, having a blast since, and yeah, we'll talk about it today.
I didn't know you and Bar were married. So yeah. Yes, okay, wow. Because Bar reached out to me around the time you guys founded, and I did not realize that. Okay, well, very belated congratulations.
Thank you.
So one thing you didn't say about yourself is that you graduated with your bachelor's in computer science at 16. Tell me more about that.
I was I at least started my bachelor's at 16. I think I was 19 by the time I graduated, but I was raised by Eastern European parents who pushed me to get great education. And I was lucky enough to live close to a university that had a program where you could join in essentially during middle school and start taking classes. So I did. I tried it out. Started out with math classes. I really enjoyed it. Really had a good time. It really challenged me. I met interesting people that were much older than me, and it kind of and I just decided to continue and to double down. And so I kind of did my bachelor's degree early. Ended up doing it in computer science. It was pretty new back then. I think I was part of the first class or second class of the computer science school. It's been a great experience that really kind of shaped my high school years and then later on my career. I'm very grateful for that and enjoyed it thoroughly. Probably some of the best years of my life.
That is interesting. I did my internship in computer science at 16, but I wasn't in university at 16. That's an interesting story. You said Eastern Europe, but you didn't say which Eastern European country.
So I was born in Israel to Eastern European immigrants who came to Israel in the 70s. So I was born and raised in Israel, grew up in Tel Aviv, and went to Tel Aviv University. This is where I did my bachelor's degree. I lived there until my 20s, at which point I moved to the Bay Area in California, which is where I've been for the last 15 years. And it's where Monte Carlo started, in a sense, in San Francisco, California. Originally from Israel. I grew up there when did my bachelor's and my master's in computer science there. Served in the military. Worked for a few years, a couple of startups, and then came to the Bay Area for grad school. So did my MBA here in the Bay, and stayed here to start a company with a classmate, cybersecurity company that called Sookasa, that later got acquired by a larger cybersecurity company called Barracuda, and that kind of brings us to the founding of Monte Carlo. That's kind of my career in short.
Well, you mentioned getting your MBA, and I was talking to somebody at a conference the other day about it was the most common route back in basically when you did it, the 2000s, early 2000s, where every programmer had to go get an MBA. My neighbor went and it was a programmer who got his MBA. And then what that person pointed out is not many people do that anymore. Do you think that that's still the route to go, or do you think that that plane of existence is gone now?
It's a really good question. I actually think, well, it's not for everybody. For sure. I don't think everybody needs to go. It really depends on what you want to do in your career, and I actually don't think you need an MBA to to be a fantastic engineer, or even to start companies and grow them. There's certainly plenty of examples of people who did it exceedingly well without ever going to business school. I think it was a particular point in time where I benefited a lot from it, in multiple different ways. It was a way for me to learn skills that were interesting to me. I went to business school probably after 6 or 7 years of an engineering career, and I kind of wanted to learn about new things and kind of get exposure to more things because I wasn't sure I wanted to do engineering for the rest of my life. I ended up going back to engineering. So what I did right after my MBA was to write a lot of code. But I really enjoyed the opportunity to get exposure to other domains and other opportunities, and honestly also other industries. I've mostly worked in defense and in startups before the MBA, and then I got exposure to all kinds of different sectors of the economy. So that was great, and honestly, it was also a fantastic 2 years where I met amazing people and and built what is still today my circle of friends and my professional network in California. I still partner very closely with many people that I met one way or another through the MBA program, and so I think it had a lot of benefit. Is it for everybody? Does everyone have to do that? Absolutely not. But it was a particular point in my life where I feel I actually got a lot out of it, and it did. If I look back and connect the dots, it's led to many of the things that happened later for me. First and foremost, the network part. I don't think I would have met the people that I work with today if it weren't for the MBA program. So I'm very grateful for that opportunity.
That's the conclusion I've come to on some of this. Is it's not your MBA in and of itself didn't teach you how to run a company well per se. What it is a marker of hard work and determination and intelligence and meeting other people who were built the same way so that you could all come together, create new companies, join new teams, do these things.
Exactly. I met my co-founder, but both of my later, I had two co-founders and then two companies, two different ones. I met both of them there during the MBA program, and honestly, I also had an opportunity. I was lucky to absorb a lot through, inspiration and osmosis. Like one particular anecdote I remember was that we used to have these like brown bag lunches, and people from the Bay Area that were working on interesting startups would come in and speak about them. And there were a lot of interesting companies that came to speak, and I listened, and that kind of inspired me to do some of the things I did later. And one I remember in particular was actually Travis, the founder of Uber, who came to speak about this wonderful algorithm that allows you to send taxis very quickly to wherever people need, or I think it was black cars at the time, black cars to wherever people need them in San Francisco. And he kind of pitched it and explained the science behind it. And Uber back then, I think, was extremely early. It was probably before it had any customers. But it's kind of, but that's the ultimately the caliber of people that you get to meet there, that you get to that you're inspired by, and so that was that was very, very helpful to me, I think.
Well, good. So the first thing you did was you were at the Israeli Defense Force, which I'll have to ask you if that, I know it's mandatory service of 2 years for IDF. That was your mandatory service. So you were a research engineer at the Director of Defense and Research, where you were working on radar deployed on business jets.
Uh-huh.
Tell me more about that.
Yeah. Wow, that was many years ago. Yes, it was meeting my mandatory service, and boys do 3 years, girls do 2 years, and so everybody after high school in Israel goes to serve one way or another. And because I was lucky enough to get a bachelor's degree in computer science before my service, which is quite unusual. You usually serve in the military and then go to college. I got an opportunity to actually do R&D, and specifically, I served in the Israeli equivalent of DARPA. What if anyone's familiar with DARPA here? It's part of the
Defense Advanced
Department of Defense.
Yeah.
Right. And so it's the part of the DOD, or now DOW, that looks at crazy ideas and projects and kind of feeding advanced technology into the armed services. So Israel has a much smaller scale equivalent of that, and I was lucky enough to serve there. And one of the ideas was that Israel is a very small country, very, very, very small, smaller than New Jersey, if I recall correctly, and doesn't have a lot of depth in terms of territory. And so if you're the Israeli Air Force, your radars that you use to protect the skies are pretty vulnerable, right? So you kind of have to assume that your ground radars will be eliminated in any sort of conflict. So the idea is, can we deploy powerful radars on airborne platforms? And that's how that project was, which are much more survivable, if you will, in this scenario where there's conflict. So that was the idea, and it's those are basically Gulfstream business jets that were fitted with radar systems, and I was lucky. I was obviously a very small part of it. Those are massive projects with thousands of people working on them. But it is probably one of the cooler technologies that I've ever worked on, in the sense that these are extremely complicated systems. These radars are capable of tracking hundreds of targets across hundreds of miles in real time, and basically provide command and control to the Air Force, right? And that's not the only thing. There's also other various systems there to help protect those airplanes and survive under a threatening environment. So super complex systems, lots of hardware, lots of software that all needs to work together. And it's a little bit of a cliche, but lives depend on it. So it needs to work well enough, right? And so that was kind of the thing that I got to work on for almost 3 years. Learned a lot. It was my kind of first job, if you will. Learned a lot, worked on lots of different sorts of problems and systems. What I also learned is that it probably takes close to a decade to build something like that before it actually flies and does things. I also learned that I want to work on things that can be built quicker and have an impact quicker. Because, funnily enough, I worked on this thing for 3 years, and I kind of didn't have the privilege of seeing it fly. Its first flight was many years after I left the service, and I kind of that in a way taught me that I want to work in startups and fast moving environments where I can actually build something and see it get adopted by people and see how they use it and where the thing needs to work better, and iterate and develop it with customers and with real world impact. So I think that's the thing that was missing for me, especially as a person just right out of college. And so that in many ways that also shaped my career later. I almost always chose to work for companies that are fast moving in environments that are iterative and where you can actually at least hope to have meaningful impact on the world. So
yeah, you heard it here first. Startups are faster than Gulf Streams.
Oh yeah, totally. It takes a long time to build a Gulf Stream.
All right. So from there, you became a senior software engineer at Genio Innovation, and you were doing some machine learning there. What sort of machine learning were you doing?
So Genio's premise, and this was probably mid 2000s. So Genio's premise was around essentially personalizing the web, right? Back then, you hardly had things like Facebook or Twitter or things like that. And what you had were a lot of different websites that you might follow. So yeah, you might follow the New York Times or Wall Street Journal or both for news, and you might follow various industry publications that you care about, whether it's TechCrunch or something else, and maybe a number of blogs and Today podcasts that you care about, right? And the idea was, can we actually create a feed that's highly personalized and relevant to people instead of them having to go to all kinds of different websites and try to pick up. So in retrospect, we were kind of trying to build what is today your Facebook feed or what have you back then. And so machine learning in that context was actually a lot of NLP. So it was about capturing a lot of content from the web, modeling it, then matching or capturing signals about a particular individual's interests and the topics that they care about, and mapping those two or matching those two so as to create a highly curated, personalized feed of web content for a particular individual based on their individual interests and needs. Of course, predated the embeddings that we have today. So lots of more, now maybe obsolete techniques there. But actually learned a lot and had a good time, and learned a lot about the importance of creating good training and validation data sets, and how to approach text processing. So and it was probably my first, I want to say it was my first foray into what we now call, data science, or maybe even AI engineering, if you will. And that was also something that later on inspired my career, because I think pretty much all or most of my professional years since then, I kind of lived in between this world of software engineering, which is where I started and where I got my my university training and all that, and the worlds of data, right? Starting from like data engineering, right? And then data science and AI and things like that. I think this was the first time where I kind of married those two. And back then, those weren't like such distinct domains. And I don't know that there were a lot of people in the world that had data scientists in their in their titles. And I kind of got the opportunity to get firsthand experience with that, and learn from people that were, I work with pretty experienced people that I learned a lot from, and also had the opportunity to do a lot myself, and get hands-on experience with this. And in a way that also shaped my career, and still today, like it's kind of funny. I haven't thought about it in a while, but if you think about what I do today, in a way, I'm kind of marrying those two worlds of software engineering and systems engineering with machine learning and AI in a way that's what Monte Carlo is all about. So I guess that was the inception of that in some way.
Well, that's what you and I were talking about before we started the show, and that is exactly why I like this show. The show shows that your career and what you're doing now, there's not this massive disconnect. It's this flow. It may not look clear as you're right there in the moment of what that flow is, but as you look back, you can see that flow, and you can see that it isn't a straight up. It may be a bit of a moving around, but there is a flow to it, and there's a reason for it. And sometimes that flow is really hard in the moment.
Yeah, you don't see it as you live through it, but you can connect the dots later. Yeah.
Yes, you get that hindsight. So from there, you went to PayPal, and you were a mobile, or your product management intern in the mobile team. But why did you make that switch into project management or product management?
Yeah, great question. So this was essentially my internship in the summer between my two MBA years. And to me, it was so I think I ended up wanting to do a product management internship because it was a good bridge between the worlds that I've experienced before, which was around software and data, and the worlds that were maybe closer to the MBA program, if you will. So, the business side of things. And so like the product role is that glue between those two worlds. And specifically, I spent my time at PayPal because there was a really interesting time in mobile. PayPal started in the early 2000s. It was probably 10 years old or so by the time I did my internship, but it was kind of starting a new or having a very fast growing part of it, which was mobile, right? It was the rise of iPhones. and e-commerce was starting to happen a lot more on mobile platforms as opposed to desktops or laptops. And so PayPal was having this like really interesting point in time where, creating a version of its or optimizing its product for mobile really mattered. It was really critical and strategic and fast growing. So it was like really, really interesting times. And so it was a very compelling. It was a short stint. It was just 2 or 3 months, 10 weeks during the summertime, but I think it was like eye-opening to me, and it actually taught me a lot about the importance of timing in the market. You could really see the market pull for what PayPal Mobile was trying to do. Mobile was happening, and the success of PayPal Mobile, it was a great team, and they built a great product. But the success of PayPal Mobile was almost guaranteed in the sense the market was pulling it in that direction. It was just over. You could see the product market fit, and that, in hindsight, obviously, also taught me a lesson a little bit about startups, and it's something that maybe I didn't see in the startups that I worked on before business school. Like both of them were early and small and were trying to find product market fit in many ways, and the pull just wasn't there or wasn't as strong. And you could see how PayPal Mobile was the polar opposite of that. It was like you basically could make all the mistakes you want and still things worked out, and the market just pulled the business in a crazy way. So that was a that is something I was looking for later in my career, when in both startups and in my time in Barracuda, which is a public company. It was much larger at the time, but I was looking to see those signs of like the market is pulling us, and the market wants this thing, and then building it becomes so much easier when there's market pull.
From there, you co-founded Sookasa. Why did you found a company after that?
So I'd lie if I told you it was incredibly planned. It was just a great opportunity. I had a classmate, a roommate, in fact, and classmate, and he was working on this problem, and we really enjoyed working together. We really liked each other, and it was a very interesting space to me. I felt it was cybersecurity. We were kind of helping businesses adopt cloud file sharing services, specifically things like Dropbox or Google Cloud. And we're helping create a layer of security and compliance for those services, so that businesses can use them in the business context. And I really liked it because similar patterns to what you saw at PayPal Mobile, right? Like this was happening. People were using Dropbox at work. They were using Google Drive at work. And then like, it became a question like, well, how do you help make it more effective or more sanctioned, if you will, from the business side, to use those services? And so the problem was really interesting. It was really exciting, and I really liked the team. And so I kind of jumped into it and joined the team, and I had a good run. Had a good 4 years there before we got acquired. So yeah, that's the why.
What was the problem your roommate was saying? He was just thinking it hit his company. I assume he was a college student.
He was a PhD student. And he was, and how did he kind of come up? So we were also working, we had a third co-founder, and the third co-founder was a seasoned entrepreneur. Actually, I think it was like his probably second or third or fourth company. And so they were looking at the market, and then they were basically talking to a lot of CISOs and CIOs and exploring this problem. And so I think that's where the inspiration came from. I don't think, well, both of us used, these cloud services as students, but I don't think we understood or knew exactly about the business challenges that come with doing that. But I think our third co-founder had an intuition to that from past experiences, and then by by having conversations with our target customers, if you will, it kind of helped crystallize and clarify what sort of problems emerge from using those cloud services in an enterprise setting.
Okay. And as you mentioned, Barracuda bought you, where you went into email protection. Why did you change from storage to email protection?
Good question. So we came into Barracuda, and this was we were doing what we were doing for 4 years, and when we came to Barracuda, we had the huge privilege of working for an amazing my boss there, who later became the CEO of Barracuda. He was actually incredible. Learned so much from him in so many ways, but one of the things that he did that were pretty interesting up front was like tell us, hey, go do crazy things, right? Like go do something awesome, right? And so it gave us the time and the space and the mandate to look through lots of different opportunities, right? Barracuda had a much larger scale, much larger footprint than we had as a small startup. And so we started looking at opportunities, and we noticed this opportunity that was actually remarkably close to what we were doing in file storage from a technical foundation standpoint. There's a lot of under the hood. These systems are architected in very similar ways, but I think the business opportunity was much larger. This was the early days of targeted phishing attacks. These emails that you get that tell you, oh, you might get an email that looks as if it's coming. There's lots of different flavors of that, but examples are like get an email from your boss saying, oh, I need something very urgent from you, and then they end up getting you to send money or gift cards or whatever. And then there's a much more sophisticated versions of that where you're about to wire your down payment for the new house you purchased, and you get an email that tells you, oh, apologies, last minute change. We need you to wire it to to this and that bank account, which is actually controlled by fraudsters. So that was kind of an emerging trend, and these things were. I think the defenses today are much better, but back then there was basically no defense against that. All of the email protection systems were based or were originally designed to protect against spam. And spam is a high volume thing, right? Like you can easily block spam, not easily, but you can block spam by identifying that there's a certain type of email that's being sent many times, and then pretty identical email being sent, a lot of times is an indicator of spam. And so all the ways to protect against these email attacks were based on volume and on deterministic rules. And we had an opportunity to actually use a much more ML-based approach or analytic-based approach, if you will, that could help identify those very targeted attacks where this is not about, you don't see a million emails directed personally to Jesse, signed by Jesse's boss and having like very unique details about what Jesse's doing. Maybe the fact that you're about to, submit your down payment for your new home, things like that. And we took a very different approach that could actually identify those things with very little, that are extremely low volume, extremely targeted, extremely personalized. And so we identified this opportunity and we decided, let's go after that. This is going to be big. And that actually worked out in the sense, it ended up being the fastest growing product in Barracuda's history, maybe with the exception of its original product that it built when it was first founded, and became a very substantial business at Barracuda fairly quickly. So I think we kind of took ideas that we developed around file storage, but we applied them to a space that was growing much faster. It was a much more immediate and urgent need from customers, at least from Barracuda's audience. So that was the reason we kind of changed it, and it ended up being a great experience as well. Ultimately, by the time we left, we led the entire product and engineering team at Barracuda with lots of different products under our umbrella, because in a way that new product became the centerpiece of all email protection.
So you were obviously doing AI there. Tell me about the observability requirements or observability issues you hit there.
Yeah. Really good question. In many ways, this was the reason the idea for Monte Carlo even started. So the way you deal with these very targeted attacks is with, I'll call it machine learning. I don't think it was AI back then. But with machine learning models that can basically predict that a certain email is malicious or is fraud, even if we didn't necessarily see it being sent, a million times. And so you basically had to extract various features, if you will, from the email, from its metadata, and try to guess whether it's, or educate the guess, right, with the model. And that was a very data heavy thing because we looked both at attributes of the email itself, but also at aggregate information that we had from, I think we were protecting tens of millions of email inboxes, and probably about 1 billion emails a day. So there's a lot of data there to learn from, and the whole thing worked only if the data pipelines and the implementation of the models behind them was working, right? It was all about whether the data is good, and the models are performing the way you want them to perform, the way they work when you develop them. And when I looked, and this is something that I probably saw more in retrospect than when I was there. The times that we disappointed our customers were not so much related to like your classic, application or infra downtime, like the type of stuff that as a software engineer, you think about all the time. It was more about those pipelines, those data pipelines failing in various ways, right? Or the data being messy to begin with. And so it kind of triggered that idea of like, oh, why is that? And the reason is that when you look at the application or infra side, you basically have a pretty well understood methodology of how to make this thing reliable, right? Called DevOps. It has lots of different ideas behind it, but one of the key ideas maybe is this idea of observability, right? Like you have a system, it's complex, so you extract a lot of telemetry from it, and you actually take the time to analyze that telemetry, to monitor it, to understand how it behaves, so that if something bad happens, you catch it quickly and you fix it, right? That is one of the core ideas in DevOps and in observability, and that is something that every software engineer kind of knows from the first day on their job, and you have plenty of tools to help you do that. That was not the case on the data and ML side. On data and ML side, it was like, wow, there was, I would argue there wasn't even like a solid methodology for it. It was kind of like, build up those pipelines and hope that they work. And even if there was a little bit of methodology, or, you could come up with something, there wasn't a ton of tooling or products you could use to do that, right? You would have to basically implement your own version of it from scratch, which we did at times, right? And that, in a way, inspired Monte Carlo, because the kind of insight behind Monte Carlo is we basically realized that we weren't the only ones. There many others, practically every data and ML team ran into these issues, right? You build the model, and it works on your computer, right? It works in the lab, but when you put it out there in production and it's serving, something that is mission critical for that matter, a lot of things can go wrong, and they do all the time. And there needs to be, an operational process, if you will, to address that if you want to deliver good, trusted data and ML. And I think most people do, right? We all want to do a good job, and that's why we built Monte Carlo. In a way, it's that experience that inspired us to build Monte Carlo.
Well, it's interesting thinking back to that time where you basically, data was in two parts at that time. There was the data warehouse people, and then there was the data scientists, and you didn't have many hardcore software engineers there trying to build systems. And so as you think about that time, I mention this because we're still experiencing this issue. People still are not realizing we don't have enough software engineers, or we don't have enough data engineers with software engineering backgrounds, which is my definition. And that's a whole problem unto itself. Your data warehouse people need to learn more. They need to learn how to program. They need to learn how to create systems differently. Likewise, your data scientists creating software engineering, software systems is not just writing code. It's creating a system, as you mentioned. It works on my machine, does not work for a billion messages. And so I wished I really wish we were further along that maturity cycle as an industry, but we aren't, frankly. That's been what I've spoken at many conferences.
Yeah,
So your take
100%. It's yes, 100. I'm 100% on board. Those are two actually very distinct skill sets, and building systems. Let's call it building systems or software, and building great data analysis or models. And very few people, in fact, understand both. Almost no one is good at both. It's a very different type of thinking, and it is still very difficult to marry the two. And now, we're seeing it in AI, or at least I feel like I'm seeing it in AI, and it's all this whole thing happening again in a it's like it's extremely hard for software engineers alone to build really good AI systems. And it's really hard for AI engineers or data scientists, however you choose to call them, very hard for them to build AI systems that work in production that scale. And it's still, I think, a big part of the challenge is bringing these worlds together and partnering in a good way to actually deliver the final product. And I think that unfortunately, in the 6 or 7 years that we've been working on Monte Carlo, we've made a lot of progress in help bridging that gap, but it still exists in the industry, and we still have a long way to go. So,
well, let's talk more about Monte Carlo, and we'll do that by switching to the whiteboard. To start off with, what is agent observability?
Agent observability. So agent observability is a new capability that we built this year, and I think to fully understand it, I'll give just a little bit of historical background about what we built prior. So when we started Monte Carlo about 6 or 7 years ago, our goal was, how do we help back then data teams? How do we help data teams build reliable, trusted products that people adopt? Right. So that's what our goal. That was our mission. That is still our mission today. But what's changed, I think, in the last year or two, and what eventually led to agent observability, is the advent of AI, basically, right? Since the launch of ChatGPT, I probably don't need to tell anyone that AI has been a big thing for everybody, both as consumers, right? Like I think most people I know use these chatbots one way or another in their day to day, but also for the perspective of enterprises, right? Of organizations. Pretty much everyone is trying to think, well, how do I incorporate AI into my business? Like, how do I grow revenue or cut cost or reduce risk or whatever it may be by using this new technology? And what happened, or that eventually led, it took a year or two, but it eventually led to a lot of the teams that we were serving, which used to be data teams, became data and AI teams, right? They were tasked with doing that transformation, essentially. It's like applying AI to business problems, right? And that created a shift in the workloads that these people were building, and that they needed to observe, if you will, right? I think when we started, it was call it 80% analytics and 20% classic ML. If I wave my hands for a bit, now AI is becoming a meaningful part of it, right? And that means that we as Monte Carlo need to help observe those workloads, right? Because again, our mission is to help these teams build trusted, high quality products, and now AI is part of it. Increasingly, every data and AI team you will talk to is building essentially agents for various business problems. It's really, really dependent on a specific industry and specific business. And so the mix of workloads has changed, and that forced us in a good way to build agent observability, which is our answer to that. Right, it's the piece that completes the picture and adds on top of that observability that we had for analytics, for ML. It adds a piece that helps with creating observability for agents, right? And if I can illustrate it maybe on the board for a second. If you think about an agent, it is ultimately a system, and I'll flip to the next slide, but it's also ultimately a system. It has inputs, and I'm a little bit slow here. So it has inputs. It goes into an agentic system in this case, and then it has outputs. And this is something that we want. Oh, thank you, Jesse. You're helping me write these down. And
I took pity on you because that looked like a robot wrote it, or I couldn't.
I appreciate that. Yeah, I don't have an iPad, so I'm trying to do it with my rollerball mouse, and it's not working. But if you think about that system, so all the capabilities that we built in Monte Carlo over the years were primarily focused on the input side, right? These agents are reading data. That's what they're using, the enterprise data, and they're processing it in order to do what they do, right? And the outputs, just to illustrate a few examples, like outputs can be, a response to a customer that's asking for support or for service. It could be it could be code, right? Agents are actually incredibly effective at generating code. It could be, a response to an internal employee that is asking a question about how to, for example, quote a particular customer that is looking to partner. And it could be a lot of other things. There's endless use cases, and all the work that we've done over the years was focused on the inputs that these agents use today, right? On the data, right? And these agents rely. This is a really important point. These agents heavily rely on data. Data is essentially the most important piece of the puzzle because AI, funnily enough, is a commodity, right? Everybody has access to the Gemini 3 or ChatGPT 5, or I forget what's the latest Anthropic model, but that's something that everybody does. And so the people that we serve, their only competitive advantage, or the only way they can actually create value to the business, is by marrying those models with with enterprise data, right? And so data observability was about making those inputs work well. Agent observability starts looking at the outputs, right? It starts looking at, like, what are these agents doing, what outputs they are producing, and spoiler, in order to guarantee the quality of the outputs, you also have to look a little bit into the box, into the agent, and understand how the agent is structured and how it's behaving. And if you think about it, it boils down to two things we need to do. that we've added as part of agent observability. One is visibility into we call it operational metrics, right? But making sure that these things are operating with the right latency, for example. You don't want users to wait too long for a response. You might look at cost. Most organizations care about running these things at a particular budget, and they need to ensure that this is happening. Otherwise, the project fails. So all these, and of course, things like error rates and kind of more traditional software failures are things that matter because they impact the quality and the final output. So all these things matter, and agent observability allows our customers to collect that information and to analyze it, and in fact to get proactively alerted when something is off, right? So that's the kind of core cycle of observability. It's getting proactively knowing when there's an issue so that you can deal with it, as opposed to letting your customers or stakeholders experience it. The other part is, and this is where I think agent observability is very unique and different to most observability problems that preceded it. There's the actual outputs, right? So imagine that the agent is working fast and on budget, and it doesn't have any obvious errors or logical issues. It is producing typically unstructured information, right? Text responses most of the times, but sometimes images and videos and what have you. How do you know that these things meet your requirements, right? How do you know that the agent actually produced the right response to the customer, or that it produced good code, or that it answered, or that it got the right quote, or whatever it is? This is where agent observability, again, is different to all past observability problems. And we use we use a variety of techniques there to help customers monitor and analyze that information, that unstructured information. Spoiler, it's a lot about evals, evaluations, techniques like LLM-as-a-Judge. And we allow our customers to do it at scale so that they can ensure that these agents are producing high quality results that meet the requirements of the business, essentially. And those are very use case specific, right? It's very different to produce a good customer service response, to producing code, to producing a news article, or whatever the use case may be.
Good, that makes sense. So just to kind of paraphrase or summarize, this is where you were basically before this whole Gen AI. It was about your input. You made a point that I thought was interesting. I had said something similar, but I think you said it even better, that your data is your competitive advantage because everybody has access to the same models. Uh-huh. There's no, even people who are fine-tuning a model, for example, at the core, it's the data that they're fine-tuning with.
Totally, yeah.
And so I don't think people have quite understood that ubiquity, or that not race to the bottom, but what's the other word? Commoditization. Commoditization of the word is the word. That, yes, Google is going to just release Gemini 3 recently, and we all have access to that. But what we don't have access to is our everybody doesn't have the same data, and that's your competitive advantage. And if you don't have your data team right, you will not be able to leverage this data. Your data will be terrible. So
exactly. Exactly.
Okay. And now you're more focused on these outputs now. And so let's go to slide 3 and tell me about the architecture that you're doing this.
Yeah, that's a good question. So I'll kind of lay out the architecture in a second. I'll just describe some of the maybe high level requirements behind it, because they will explain how we chose to tackle this. So one of the key or probably the two key requirements that we wanted to, or three key requirements. One is we want to be, or we need to build a solution so that we can track all those metrics and all those outputs and be able to analyze them, right? So we need to store them somewhere, and we need to be able to essentially monitor them, which means, aggregate them in various ways, and test them against various conditions, and then also provide all that raw information to teams. So that's probably requirement number one. Requirement number two is, so we serve by now we serve around 500 organizations. Many of them are enterprises or fairly large companies, and at least some of them operate under a lot of scrutiny from a security and compliance perspective. In fact, at this point, almost every company in the world is operating under some constraints in terms of security and compliance. And so we wanted a solution. We wanted a solution that allows all of that agent data to be in the customer's control, in the customer's environment, owned by the customer, because that is a key requirement for many of our customers. And agents in particular tend to process very, very sensitive data. They usually process very personal information. It's very open-ended. You don't exactly know what the agent is going to be asked and how it's going to query the underlying data. And so, security and compliance is front and center for us. And the third requirement, we built this for production, right? The whole reason that we exist is to help teams productize these things, right, and put them out there at scale to, sometimes it may be hundreds of internal users, and sometimes it's millions of external users, but it's a significant scale. And so we needed a solution that gives scalability, both in terms of capturing all this data, but also in terms of allowing this monitoring thing to work cost effectively. One of the challenges with evals is that they are they use LLMs, or especially not all of them. There's also deterministic variants, but a lot of times it will use LLMs to evaluate the quality of agent output, and LLMs are expensive. If you run a million outputs through an LLM individually, that costs a lot, and there's only so much money you can spend on monitoring and observability, right? It's by definition it's bound by budget, and so we needed a solution that allows us to do all of this at a cost efficient manner. What we came up with is there's probably 4 stages here, or 4 boxes, if you will. I think. Let's see if I got it right. So at the start of the pipeline, if you will, is the agent, right? Is the customer's agent, the agent that they built, and we've built an SDK that helps emit telemetry from the agent. So it's basically a Python package that you import into the agent's code, and it would start sending out all of that information that we talked about, right? Like all those operational metrics around latency, cost, errors, and also all of that unstructured data, basically the inputs and the outputs to models, metadata about the agent, metadata about tools that the agent is using, things like that. Technically speaking, under the hood, these are traces and spans. So we could talk about what traces and spans are, if you'd like. But it's basically very granular information about all the different nodes that executed within the agent, if you will. That information is emitted into an OpenTelemetry collector. So that data is exported under the OpenTelemetry standard, and it's captured by a collector that our customers host in their environment. So this is not something that we control, for that matter, or see. And the collector feeds that information into the customer's data warehouse, right? Maybe there's Snowflake or Databricks or BigQuery or Redshift or what have you. And so all of the telemetry from the agent is stored in the customer's environment in their own data warehouse. And that is a really important point in satisfying requirements 2 and 3. So I'll explain in a bit how we then do observability and monitoring on top of that. But this is a really, really key part of the architecture, is that our customers get all the data, and this is a really, really sound solution from a security and compliance perspective. By the way, it has we've found from our customers that it also has other benefits. One of them being that they can take that data and then expose it further to their customers. So, for example, if they want to expose telemetry about agents to their own internal or external customers, it's something that they can do because it's not data that they have to pull from Monte Carlo from us. It's something that they own, that they have in their own infra. And another one is that you can actually, it's a really interesting data set, and you can actually join it with other data sets you might have. For example, you can start looking at how interactions with agents impact user behavior later, or business outcomes, things like that. So it gives an opportunity to correlate the quality of agent interactions with business outcomes in a way that's extremely difficult, right? Otherwise. That's the 3 boxes we have here are kind of the foundation of the observability solution. Now, just to share context, Monte Carlo is a SaaS solution. You use it in the browser. You go to getmontecarlo.com, for that matter, and it's a web application. So how does that application interact with that telemetry, with that data? There's 2 things we do in order to allow that. One is we have a periodic job, if you will, that pulls out metadata from the customer's data warehouse, right? So we will collect non-sensitive non-sensitive metadata about agent executions. Things like, well, what spans even exist? And some of the operational metrics are not very sensitive. Things like runtime are pretty non-sensitive. So we can bring that over. And this helps the application, the Monte Carlo application in the cloud, basically map the agent, the customer's agent universe, if you will, starting from very basic things like what agents are even running there, and things like what is the exact tree that these agents follow. And for those of you who have built agents, you probably know agents are typically sort of a graph or a tree of nodes, right? Each node represents a step, and a step could be lots of different things. Typically, might be making a tool call in order to fetch some piece of data, or it might be a call to an LLM model in order to process or transform or synthesize that data, or it might be a call to an LLM in order to make a decision, right? And take all the information to decide what the next step might be. So there's lots of different kinds of nodes. Our cloud application can actually take all that metadata and reconstruct the execution, right? It can understand what agents you have and what specifically what steps of execution, what nodes each one of those agents execute, and it can also understand certain operational aspects, latency, costs, things like that, which are not sensitive. So most people feel comfortable getting them on the cloud.
So to be clear, you're running your LLM checks here in the cloud, not here on customer, or is it either or?
So that's the other piece. When we do want to evaluate the inputs and outputs of agents, right? When we want to actually look at the completions, that is not something we can do based on non-sensitive metadata alone, right? That is something that requires actually having the actual text that the agent processed, and that is on the customer side. That is not in our cloud. And so when we actually run this, this monitoring, this is actually a query or a job that is triggered on the customer's data warehouse, right? So it is triggered by our cloud application, but it is executed in the customer's environment, essentially a query to the data warehouse that runs those inputs and outputs against LLM-as-a-Judge models that run in the customer's environment. And that might depend on the stack. For example, on Snowflake, we'll use models that run on Snowflake Cortex. And there's similar constructs in other data warehouses that allow us to actually run all of the evaluation in the customer's environment, right? So the metadata goes to our cloud so that we can have a pretty snappy UI experience and help our customers understand their agents and their executions. But when it comes to processing the actual sensitive data, the inputs and the outputs, that gets pushed down into the data warehouse. That's essentially an aggregation that runs on the data warehouse.
I was at a dinner party. Well, it was Thanksgiving, basically, and they were talking about AI, and they're lay people. They're not in the industry, and they were completely surprised that we use LLMs to evaluate our LLMs. It's
pretty crazy. Yeah.
It was pretty funny to them because they were trying to figure out, will it take over the world? Will it take over all of our jobs? And I say, well, right now, our LLM that's running over here is now evaluated. It's elephants. It's
all the way down. Yeah. I don't think personally. I doubt we'll have agents taking over the world this year, but in their defense and to their credit, that's also how we humans do it, right? We peer review each other's work, and that's how we measure ourselves. So, I don't think I think it could work. Let's see. But
it
it is
wasn't
an
so much
effective method.
that they were surprised that was what it was more that they thought LLMs were just one shots, to use our parlance, and they weren't realizing that there is a one shot to it. We're not on the hot path, or we're not on this path where if agent goes out to whatever was calling it, but there's still an evaluation, or even with, for example, some even Gemini, those other models, their responses are dealt with on the hot path for any sort of violations of what you're saying, what you're doing. Are you trying to figure out how to make a bomb? Are you trying to do something nefarious? That is on hot path as well.
Yeah. It's a pretty crazy idea. Very impressive the progress that has been made in this space in the past year or two. Pretty cool.
So did I draw this out all right? It looks.
Oh yeah, this is exactly right. This is exactly
okay. Yeah. I'm not paid for my looks anymore. I can draw pretty pictures of diagrams.
No, this is great. This is great. I wish I could draw it as well as you do.
Yes. Yeah. In fact, you brought out something that I thought was interesting that's worth talking about, and that this analytics side, where people were actually using your data exhaust in a positive way of saying, oh, now we have everything that our agents have sent. Now we can use that. I was surprised you didn't say something like I wonder if somebody's tried to look at client engagement based on this. That based on this, you could actually go through and say, did we have an uptick? You could do some A/B testing on, did we actually improve sales? What have you?
Yeah,
has that happened?
Right. Yeah. Well, early days, right? I think it's early experimentation, but yeah, this is exactly what people are trying to do, and having all that telemetry there opens up that possibility of tying together the revenue, for that matter, to agent performance.
Interesting.
Yeah.
Okay. You also mentioned briefly what was it, struts, that you said if I wanted to talk more about it was something on the agent side. I can't remember what.
Oh. Yeah, it's basically it's kind of an interesting thing. Like, what does this telemetry even look like? And technically, it's structured as traces and spans. So traces and spans. It's actually a concept from classic observability, right? It exists in almost every observability framework you'll find out there, and it's a way to describe the execution of a system. So specifically, a trace is something that represents typically one single execution of the agent. So think about, like, you're giving a prompt to Gemini, then the process that ends up in you getting a response to that prompt is described by a trace. And a trace is made of several things. One, metrics, right? It tells you things like, when did this happen? When did it start? When did it end? How many errors it had, things like that. It also includes metadata, right? And there's hundreds of potential attributes there, but like think about like maybe what version of Gemini I ran there, and what data center it ran in, and what is the name of the application, and things like that. And then it also includes what we call child spans. And child spans is what breaks down traces into those nodes that we talked about, right? Like an agent in the end is a collection of different nodes that execute, again, whether it's tool calls or calls to an LLM model, or other types of processing. Each and every one of those is modeled by a span, or sometimes multiple spans in practice. And spans describe those individual nodes and are essentially a tree that comes out of the trace. So you can actually think about it as a tree. At the root of the tree is a trace that represents what Gemini needed to do to answer your prompt. And under it, lots of nodes that are modeled by spans that give more granular information about individual parts of the processing. So, for example, if you're thinking somewhere there, you brought up the example, maybe there's an LLM call there that tries to evaluate whether your prompt is about trying to build a bomb, right? Maybe Gemini does that under the hood. That might be represented as a single span within that trace. And that span will actually have detailed information about the LLM call. So, for example, it will have the input or the prompt given to the LLM. It will also have the completion, right? Like what the LLM responded to that input. And it will have valuable metrics like how many tokens were processed there, right? Which could help you understand the cost of that particular span. And so this very detailed and granular information is what we capture from the agent and what eventually gets into the data warehouse. So it's basically a lot of spans that are structured as trees called traces that we can later analyze offline, basically.
Okay. Is there anything else you want to talk about in the architecture of this?
I think that's a pretty good overview of the architecture behind agent observability.
Okay. Since you've been able to talk to a lot of customers, what are you finding that's difficult for them to get right, or is an impediment to success in AI projects?
It's a good question. Certainly, there's a whole set of problems. I think this is a pretty common thing. It's incredibly easy to not easy, but it's incredibly pragmatic to create a wildly impressive demo of what agents can do. It can sometimes pretty impressive things can be done within days, right? I'll give an example from our world. And every time I talk to a customer, there's a similar story. There's one particular challenge that our users have, which is troubleshooting problems, right? We're an observability solution. We send alerts to people when things break, and then they have to go ahead and investigate why it broke, right? And there's a million reasons why data or agents can break, right? You could have a faulty data source. You could have failures in a job. You could have changes in the code that have some unintended consequence. And that can be a pretty tedious process that, over the years, we've captured a lot of telemetry to help with it, and we've built user experiences around it. But this is something that felt like it lent itself pretty well to using an agent, in the sense that an agent can generate hypothesis about why a particular issue happened, and then bring over all the telemetry data that might be relevant and try to correlate it or synthesize it in a way that can help guide a human in finding the root cause of problem. It can at the very least, narrow down the options quite a bit and guide the human into, here are like a couple of things that probably caused this that you can look at, right? And so this felt like an interesting idea to us by now over a year ago, and we pretty quickly got to a prototype that can produce extremely convincing results around this. Right? I don't recall exactly how long, but a matter of a few weeks. We had something that worked pretty well in a pretty broad range of examples that we were looking at. It then took us probably nine months to get to production, actually, deliver it to our users. And that is fairly typical, I would say. The distance to prototype is oftentimes very fast with AI, and then the distance to delivering it in production is orders of magnitude larger. And there's a bunch of different reasons why it happens. And we talked about some of them earlier. So part of it is creating effective collaboration between different skill sets, right? How do you take that, non-deterministic, quote unquote, scientific approach that that the AI engineers bring into the equation? How do you translate it to something that software engineers can put in production and know that it's going to work well? A big part of that, by the way, is the ability to evaluate and observe the thing in production, right? I know it sounds self-serving, but it is actually one of the bigger challenges. How do you know the thing works? How do you know that it works before you ship it, and how do you know it works once it's in production? It's a really big challenge, and we're a 200-person company. Some of our customers are much larger enterprise, many of them, and the stakes in a sense are even higher there. Like there might be certain governance and quality and security hurdles that you have to meet in order to ship the thing, to actually deliver it in production and get the business impact that you were hoping to have. So that's a huge deal, and we've experienced it ourselves. By the way, security as well. By the way, wasn't like it took us a long time to figure out the right security architecture, because it's one thing to run a prototype in a notebook, in our own data, in our own environment. It's another thing to make this whole thing work with customer data in an environment that has tight controls and tight rules about what you can or cannot do. And that's a challenge as well. And I think each and every one of our customers is kind of running into that. I'll probably call out the other thing that is increasingly coming forward that I see is how do you measure success or ROI on these things? And I think in the last 2 years, and probably in the next couple of years too, for the most part, it doesn't matter. People are willing to invest in AI almost blindly. It doesn't matter. Just do something. Just experiment. Just try it out because I think people have high expectations for what AI is going to do. But ultimately, people are going to have to reason with or want to see tangible outcomes of how it made the business better, how it again drove revenue, reduced costs, and that is oftentimes difficult to measure. I'll give an example from my own world. We've actually, like a lot of organizations, we've adopted code generation tools in our own engineering team. And it's great. Everybody loves it. Most of our engineers use it every day. How exactly do you measure how much more efficient we are in terms of building software? That can get pretty tricky, and it's not always evident in the standard, quote unquote objective metrics, right? And so, and I think you'll see similar patterns in a lot of business domains and lots of different kinds of use cases. And so that is not yet a big problem in the sense that AI budgets are almost unlimited right now. But I think a lot of people are starting to think through how they might evaluate the success here, and it's still very, very, very challenging in practice.
Yes, you had said something interesting when you were talking about that measuring success. Yeah, this is part of why people call this a bubble. Is here we are in the industry talking about there's virtually unlimited budgets for this, but that will eventually go away, or there'll eventually be something that's some accountant saying, "What did you do?" Some sort of measurable thing that we need to do. So. This also harkens back to the early days of data where everybody said just stand up a Hadoop cluster. Eventually, somebody comes and says, what does this Hadoop cluster do? What does this AI project do? And so as you're on those teams, as you do those blue sky things, try to figure out what exactly you're doing. What is a good measure of success? And so the issue there is usually tech people don't know what that measurement of success is. And that's because there's no business people in the room, or the business people and the tech people are not talking. So if you're in a room and you're a bunch of tech people saying, what are we measuring success on? And there's no business person in the room to pipe in and say, well, this is what it would be.
Yeah.
You're not functioning correctly. You're not integrating. You're not collaborating. And so I put that in there. So it's data science and data engineering, and it's business. Sometimes it's just this one, and that's not right either. It's not these two. It's all three of these things.
Absolutely, 100%. It's and it does ultimately to keep these initiatives funded and maintain momentum. It's so important to bring the business over and to understand how to drive the metrics that matter.
Okay, so switching back to, so you mentioned something at the beginning of this that I didn't realize, and otherwise I would have asked different sets of questions. So I was going to ask you originally about some of the stuff you said on LinkedIn, but now, if you don't mind, I'll avail myself of you're the first husband and wife team that I've been able to interview. I've interviewed other founders where they've known their co-founders for 20 years. They're more like brothers. But here you are, husband and wife. And tell me more about that dynamic. How did you find this good either operating procedure, or did you nicely fit into that already? How did that work?
Yeah, good question. There was a big, to be honest, it was a big dilemma whether to partner together. And, for context, my Barra, my co-founder, is the person who left her job probably a year before Monte Carlo actually started, and decided she wanted to start a company. And I was just helping her, as a family member, right? And we ended up deciding to actually partner together. The original intention, by the way, was not for me to necessarily join her, but we ultimately decided after close to a year to do that, and I left my job and kind of joined her and to start Monte Carlo. And we debated it a lot because it could end in tragedy. If I'm blunt for a second. And so we did decide on some ground rules before we started, and it evolved over time, but it's things like, we're pretty open about the fact that we're married. Everybody in the company knows that, and generally speaking, you'll find it on the internet. It's not a secret by any means. But we decided that when we're at work, you wouldn't be able to tell that we're married, right? We need to behave at work as if we're, normal co-founders that are not married. And the exact thing is also true at home, right? When we're together, when we're with our kids, you should be able to tell that we're working together, right? That's an example. It's obviously hard to implement. I'm sure we don't quite live up to that standard, 100% of the time, but that's one of the guiding principles, and something that we try to implement. And it's very important, for both, like, to function as a family. We need to keep the business out of it, and at work, people in the company need to trust us and know that we're not favoriting each other. We don't go and talk in the kitchen, make decisions about the company, and then come back and tell everyone, right? Like, work happens at work, with other people involved oftentimes, right? It's very rare that Bar and I actually, make a decision, just the both of us. You could probably count it on less than one hand the number of times it happened in history. So, this is one of the guiding principles that we operate under, and then that helps kind of make things work. Another principle is like, that makes it effective is, like, we both have our unique passions or domains that we're excited about, and there's minimal overlap. So I really like product, I really like engineering, and that's not the background that Bar has, and vice versa. Like, Bar really loves, the go-to-market piece, if you will. Creating a category and just creating the vision, and working with our field team of customers, and I don't intervene in that too much. And we all have we have very clear responsibilities of who does what and who makes which decisions, and we're extremely respectful of that. We obviously give each other advice and help and consult, but it's very clear who's making the decision on any particular topic or any particular decision, and we can and we respect each other's work, and it's something that we've kind of learned over the years working. We didn't work with each other before. We knew each other obviously for a long time before we started the company, something like a decade, but we never worked with each other. And what I can say that's pretty cool is that you kind of learn to know the person in a new way. Like, I knew about Bar's work, but I didn't know how she actually works. And seeing her do that in person, has given me new, a new type to respect to how she does things and how good she is at what she does. And that's, also part of what helps create, a great working relationship, if you will, right? Like, I think, you always respected the person, obviously, but now you respect them even more in a new dimension in the professional, on the professional side. So, yeah, luckily, it not to be taken for granted. We're still married. We still love each other. We have 2 kids together. Like, the working relationship in a way just strengthened our overall relationship as opposed to destroying it. And we feel very grateful for that.
That's very good advice. So is that the advice? Let's say somebody is thinking about doing something with their significant other. Is that about the advice you give them? Good ground rules, talk up front, that sort of thing.
Yeah. And yeah, I think, it's not for everybody, but I would definitely, recommend it. It's not as hard as it seems, in a sense. There's a lot of good stuff that you get. You do get to do a lot of fun things together as part of work, and it feels different to do it with someone that you're also close to as part of your family. And career priorities are very aligned. Like, we don't need to, when one of us has to do something full work and maybe the other person has to pick up things at home or with the kids, it's something where we're like 100% aligned because we're trying to, build the same company, and we deeply understand what needs to get done, and we're very aligned with that. So there's a lot of good stuff that comes out of it, and I definitely, for those people that are considering it, I would definitely say it's worth a try.
Well, Lior, thank you so much for coming on the show. I really appreciate it, and thank you for sharing so open.
Thank you, Jesse. Great questions. Thank you for forcing me to think through my career. It was a good learning for me, and a good reminder of how I ended up here.